In this video, I'm going to talk about very important questions often people ask themselves, which is data science for me? So before understanding whether data science is a career option for someone, it's important to understand what data science is. And frankly, there is no clear definition of data science. And when people started giving different definitions, there was a controversy as to whether there is this is a different science from statistics or machine learning, which were already there before data science came into picture. Okay. Well, there were in industry we'll see people calling themselves statistician, analytics professionals, and now they're calling themselves data scientists. Okay. Now, if you go to LinkedIn, and before 2005, you won't find anyone calling himself data scientist. But now you will see, these profiles flooded on LinkedIn, and many people are calling themselves data scientist, which is okay because it's evolving, and it's always good to use a more appropriate acronym to describe oneself. So one of the things that is common between all the these jargons or acronyms that I've used here is that you use a lot of mathematics, statistics, and then you use a lot of things from computer science. You use a lot of programming, coding, and then you of course use operation research. So data science, from a technical point of view, has this full these things. It has a lot of mathematics. So it dates back to even 100 years, many 100 years ago. People what have done in mathematics is currently being used. Although people don't realize that the theory has come from over 100 years. For instance, those who are familiar with some form of data science, and for beginners, I'm sure they won't be able to relate. But those who are familiar with some form of data science, this must be knowing that optimization is one of the de facto, one of the main thing in data science, right? And there are many optimization routine, and you might have heard about the Newton reaction, the quasi-Newton, right? So these algorithms were invented long ago, over 100 years ago, right? Similarly, many statistical theory, whether it's hypothesis testing, whether it's statistical inference, all that has been developed long ago. Computer science, fairly a new field compared to mathematics and statistics or theoretical physics. Computer science fairly new, but a lot of what people use in computer science, whether it's the measuring the computational complexity, or doing data, or doing machine learning or neural net or artificial intelligence, all of that has been part of computer science for long ago, and that's what mostly people use nowadays in data science. Programming, there's no question about the fact that data scientists use a lot of programming, okay, and programming languages. Operation research, often people forget to cite that operation research has a big role in modern data science, but it's the fact that people use operation research, which is some form of applied mathematics and being heavily used in modern data science. So technically, these are the areas that you will be working on when you become a data scientist. And this was controversial initially to use data science, by the way, but now it's being accepted worldwide, whether it's universities or companies. Everyone is using this. When I had this problem of using data science some time ago, but now that everyone is using it, it's okay to call oneself as a data scientist. Although some people have this hesitation of calling themselves scientist, because when you're calling yourself scientist, you're actually supposed to do some scientific research. But most data science actually don't do scientific research. They rather do industrial research, which is somewhat different from the pure science research. Okay, so historically, if you look at the quantitative research or doing or using data or maths to do prediction or do forecast has been there for a long time. Actuaries has been doing it for a long time, right? The French mathematician Louis Bachelard, he wrote a very famous paper on predicting prices or returns on stock long ago, more than 100 years, and that's being used, although that's wasn't in use right after his publication, but a few decades later that paper was taken very seriously by the practitioners. And one of the most important thing that happened in history was in the Second World War. So in Second World War, the US government built nuclear bomb, and many theoretical physicists actually worked in that. And often you would wonder why theoretical physics have to work in such a project. When these theoretical physicists used to use data, they used to do simulations to do a lot of predictions that was about to happen when the bomb was tested for the first time, was used for the first time. Okay, so use of data for prediction isn't a new thing. It was there in use for the many scientific for both for academic uses and also for military uses, and also for in few areas of industries, but not all areas. Actuaries used to use it. It was also used in oil and gas industry, but many industry never used for a very long time for various reasons. Lack of data, and fact that nobody was using was also a thing. And also using data for prediction is used to be very expensive, which was also adding to it. So when is the first time that people started using scientific research in industries? So often people use it in a way to criticize the fact that many scientists are now being used, more scientists are now being working in industry than they are working in actual science. But the fact that even industrial research has become more of a scientific research, and it's primarily because there is easy data collection, there is availability of cheap computational resources. What used to be available for academicians is now being available to smaller companies and medium-sized companies. Large data sets, especially digital data set, a lot of data can be easily captured nowadays with with internet and smartphone apps being in place. You can use a lot of data for sensors. It's important to say that you get a gigabyte of data from different sensors, and then that's a very large data to analyze. So easy to get such data sets nowadays. That wasn't the case some time ago. Open source softwares, open source has been there for some time, but especially for data analysis, this wasn't available for quite some time. But more recently, the advancement of R and Python, which are open source, and other languages like Java, Julia, it's been very helping data science to grow. And most important is the massive success in finance industry. Okay, so people who understand what happened with finance in the mid 70s and then later in 80s and 90s was that many people from scientific research, especially physicists, I think computer science wasn't a very popular discipline in those days. Probably it was more of a starting to be famous in academics. But physicists, especially theoretical physicists, used to work heavily with maths and data, and they used to use computing to solve physics problems, and they switched career and became quants and used data and algorithms to solve problems in finance. And they became heavily successful. Many Wall Street banks started investing in quantitative research, and they hired all PhDs in physics, applied maths, and engineering, and so on. And they were heavily successful, very successful. They were very well paid. People who were quant in those days used to be very well paid. And because of this success, many industries actually started looking out for quantitative research people, so that they can also leverage data that they have and be as successful as what people have done in finance. So that is one of the main reasons why other industries started using data for their decision making and for automating things. Okay, so the main question for us is this for me? So till this point we were talking about what data science is and what's the history of data science and quantitative research. Question is now, is this for you? And I also asked this question to myself, is this for me? Although when I was a student, I had never had an idea about what this is, and I came into this field accidentally. But many of you probably, given the fact that now it's a lot of content is there on the way, we can do a search and see whether this is for you. It's important to know that the skills needed to become a data scientist or to become an analytics professionals in industry. So a lot of this talk that I'm going to do is specifically targeted for people who are interested in industry, and those who are interested more into academic side of research in data science probably won't find this useful. Okay, so skills that's needed is quantitative bent of mind. It's good to have some sort of interest in numbers, and hence maths, specifically applied maths. If you good at theoretical maths is okay, but good to have interest in use of maths. Like you may not be able to explain theorems or prove theorems, but should be able to apply theorems or apply mathematical techniques or algorithm to solve real world problems. Okay, programming. Okay, somebody with coding experience and somebody with interest in coding experience is someone who will fit into this area. So these are two important skills, technical skills, but there are also non-technical skills needed, which is ability to solve problems. Not everyone is good at solving problems, or at least having an interest to stick to a problem and solve it. So this is certainly not a repetitive job that you would be doing. And then interest in business and domain, and this is quite important. One should have interest in learning business, which is not quite a thing for especially geeks, right? Most geeks or people who take a lot of interest in technical things have interest in learning business. So it's difficult for companies to find people with both skills. I was talking about quants, right? So quants especially the younger quants used to find it very difficult because they had no idea what's banking or finance or what capital market was all about. They knew stochastic models, they knew statistical data analysis, they knew a lot of theoretical physics stuff, such as statistical mechanics and so on, where they used to use a lot of data and algorithms, but nobody knew what finance was, and they had tough time. But eventually they learned and did very well. So getting people who are interested in both sides, both quant programming and business, is very difficult. And if you can become someone with both interests, then you will be invaluable and you will be liked by the employers. So a few scenarios, like if you're already an employee and you are already a developer or a hacker, it could be already a marketing professional or sales professionals. Now the approach towards becoming a data scientist is different. Now remember one thing, that data science is again is not a very well defined profession till today. Although many people will disagree with this, there's no there is no concrete definition what data science is till today. So that there are different aspects of it, and you should know which aspect of data science that you will be able to relate, or you will be able to do well. So if you're already a developer and you're a very good programmer, okay, you know coding very well, so which kind of data analysis you should be doing? Well, there's a lot of scope in doing automation activities nowadays, whether it's image recognition, voice recognition, natural language processing, or building products that does predictions, like recommendation engine. Such things will be very suitable for you, but it's not very suitable for you to become a quantitative researcher in finance. Although many people have successfully done that, those who are very good developer in IT industry, they have become good quants. But then there are a lot of opportunity already there in IT industry, which you can leverage with your developer skills, right? So there is no point going into financial research if you're already a developer. If you're a marketing professional, sales professional, HR, more into non-technical side of things, more into business side, will you become a data science, or by learning data science will you benefit from it? Well, yes. Well, data science has primarily two types of problems. One is prediction problems, or one is insight, or in technically we call that as inference. So a lot of people confuse with this. The prediction problems are like automation problems, image recognition problems. You're always predicting something in future and automating through programming. But data science is also used for decision making. Okay, for instance, which stock to picking stock, or which is the best way to spend your advertisement budget. Whether it's social media, whether it's TV. So that could be one area, right? So people with marketing cells, or which individual is to be hired, which to be given promotions. Okay, so all that will need statistical data analysis, and although these are prediction problems, but it should be done in a different way. You cannot simply automate through an ML algorithms. So your marketing decisions, whether your HR decisions, cannot, or even picking stocks, cannot be simply automated through a machine learning algorithm. It has to be done through more theoretical research and having some sort of domain into it. Okay, so this would be more of theoretical statistical research than pure machine learning research, or artificial the AI research rather. Okay, so for non-technical people, this area is somewhat better, although there is no entry barrier as such, but somewhat better than getting into automation or image recognition, voice recognition, NLP, and so on. We're already into some areas like finance or economics. Then you can get into quantitative research very well, and then you can also do a lot of predictive algorithms in regulatory research in banks, and these people also can get into this field. They can as well get into this field, especially if they are good at coding. If you're not an academician in science, technology, and social science, you can also get into the above three fields, depending on what your interests are. So often there is a confusion whether social science people can get into this. Well, there's no doubt about the fact that science and tech people can, but even social science people do. They actually can, especially people with economics, sociology, psychology. Such people can easily get into data science research, because they use statistical research in their day-to-day research activities. So someone with masters and PhD can always get into. For students, If you have a CS or statistic background, it's very straightforward. It's very clear for you that this is one of your hot career. But people with maths, physics, engineering backgrounds, those who want to come to this into this field, they can take few CS and statistics course and get into this field very easily. Okay, for them also it's not very difficult. People with economics and finance degree, they can get into more of a banking side of data science or quantitative research, which do not quite require a lot of coding, but rather require a lot of statistics and finance knowledge, right? So they will find this very easily. Accounting, liberal arts, and people with journalism background, they can actually use data science in their day-to-day activities, and if they want to come into this field, they can easily come with certifications. Okay, so important thing is that someone with completely non-technical background can also get into this field. So all you need is coding and data analysis skills. No matter what you're doing, which academic area that you are learning in college, if you have sufficient coding and data analysis skills, you can always get into this field. So what matters is academic background should have a proper academic qualification to start with. Career path, whether you are interested in academics or industry. If you are interested in industry, ensure that you learn industry very well and use your tools and techniques, because classrooms, professors will least likely to discuss industry problems. They will mostly talk about academic publications and research. So one should be able to relate to the industry problems. That's important. Publications, and that you will do it through internship, right? If I have some intensive experience, you will be able to relate better. Publications, patents, and experience, always good to have on your resume. Choice of industry, people in Ivy Leagues universities in US have this confusion whether they would go for a job with Google or Goldman Sachs, which are equally rewarding, but the quality of work or the kind of work will be different. In Goldman Sachs, you will do quant research. In Google, you will be developing products. Well, both would need data scientists with good quant and programming background, but the work will be totally different, right? So it all depends on what excites you, whether it's product development or whether it's algorithm development that will be used for investment purpose. Whether you're interested in product or services will determine whether you will be joining McKinsey's or some consulting firms data science team, whether you will be using product development teams in Uber or Yahoo or Google or Amazon. You want to be hardcore data scientist or leader in data science? All depends on what you want to be. If you're a hardcore data scientist, you have to spend a number of years working as an individual contributor. Whereas if you want to become a leader, then after a few years you have to sort of get into leadership roles, and you have to get hands of many areas of data science, not just a single area. Okay, so whether you want to be a specialist or a generalist, it all depends on what your career and ambition, what interests you. Technology versus business. If you're more into business side and less into tech, you're more into tech, less into big business. All depends on what you want to. Data science will be invaluably important to both such people, whether you are a business guy, whether a tech guy. But all depends what you want to do. So an MBA can use data science. A PhD in mathematics can also use data science. So the approach would be of course different, but it all depends what you want to do. And often this is a question asked, like how to enter into this field. Any degree is important, bachelor's degree minimum. With a master's, PhD is always better. Some coding experience, general purpose coding experience, Java, C#, Python, or more statistical programming experience like R, SAS, MATLAB, data manipulation, data querying language such as SQL, PL/SQL, and so on. Good ground of statistical theory, irrespective of what your background is. whether you have studied psychology or sociology or computer science or physics or engineering, one should be comfortable with statistical theory, statistical inference, p-values, linear regression, assumptions of linear regression, inference, um, time series analysis, panel data analysis, and so such things. Machine learning. So, what's prediction problem in machine learning? Why a lot of this assumption is statistical theory are not very important in machine learning? So, is that the distinction is quite important. Machine learning algorithms like decision tree, like ensemble modeling such as random forest, support vector machines, linear discriminant analysis, and so on. What is cross validations? Not very popular in statistical theory, but very important in machine learning. Model selection, dimension direction, feature selection. So all these things have to be one should be comfortable with, irrespective of what your background is. And then all that can be learned through MOOCs, through Coursera, through Udacity, through EDX, watching YouTube videos, attending boot camps, participating in contests like HackerRank, Kaggle, and so on. Most important is well-written CV. So it's quite important to write a good CV. In fact, this is one issue I see with freshers, that who don't write a good CV. So always highlight your projects, what you have done. You should have all the keywords, like all the algorithms that you know. So write about it in your resume, and all the MOOCs that you have attended and you have completed the certifications, you should write about it. So these are areas where one should focus on in order to enter. So first question, that whether it's important or whether it's for me or not. So the only answer I can give, the short answer to this question is that yes, it's for you, as long as you are comfortable with this presentation. If you think that this is somewhat scary and you're not very comfortable with it, then you probably have to do more research about it, whether it's actually for you or not.